Hello and welcome to Technical Utkranti. Today we'll learn something about functions. For that, the first step is to understand how memory allocation happens to variables and functions. So wherever we use external keyword with a variable or a function, there the memory allocation does not happen. It is just to show that this particular variable or a function exists, and at the stage of linking you will find it somewhere in some or the other library. The third case is the extern keyword is used, along with that the initialization value has also been put. In that case, compiler thinks that the programmer has inadvertently put the extern keyword in the program, and the compiler just ignores the extern keyword and the memory allocation will happen. I'll illustrate this thing with the help of a program. So here the memory allocation has happened. Okay, so how would I show it is, the program executes. Now let's assume that I declare another variable as in extern int, and let's say data. Okay, and now if I try to compile it, it will compile because we are not using this anywhere. Now let's assume that I use this here, then it will throw the error undefined reference to data. So what is the use of declaring something as an extern? Declaring something as an extern tells this program that okay, you continue with compiling for a few steps, and at the stage of linking you will find its definition in some other library with which you would be linking your object code. So let's see. So cpp qsort.c will change to qsort.i at the stage of pre-processing, which is the first stage of compilation. So when I do this, it is running fine. The second stage is assembly, which is this. Here also it is running fine. The next stage is asqsort.i minus o qsort.c, not I dot s, assembly to object code. This also runs fine, but when the final step of linking has to happen, which I will do with this command, this will fail because it has not find the definition of data anywhere. It has not find the variable data in the memory anywhere in any library, so it will fail. Okay, so I hope this thing is clear for us now. The third scenario which I had not told, I will tell now. Okay, now if here itself I allocate it a value of 5, then what will happen? Then let's see what will happen. It has compiled with a warning. Earlier it was not compiling only, because the compiler thinks that the programmer has inadvertently put the word extern, and it allocates the memory here itself, and later on we can use it also. Okay, so now we move towards the functions. Okay, so same goes with function. If extern keyword is used, memory is not allocated. Extern keyword is used, memory is not allocated. Extern keyword not used, memory is allocated. And if the extern keyword is used along with the logic of the function, then memory is allocated along with the warning. You can try this experiment by yourself. A short hint would be the printf function that we use comes from standard input output.h library and header file, and it is present there as an extern, that's why we could use it while writing the logic of the function, and later on at the linking stage the logic of printf function comes into our binary and that's how it gets executed. So we will not see this with the help of a practical example, you can try it yourself. Okay, so once we understand how memory allocation happens, we can see the definition between what is declaration and what is definition. Declaration is the indication of presence but no memory allocation, whereas definition is whenever memory allocation occurs. Okay, so both variable and function should adhere to this definition. In C, for a variable function definition and declaration, they are same, like declaration definition are same except for the use of extern keyword. If we are using extern keyword, then only there is variable declaration. Okay, whereas in all the cases definition and declaration will happen together. For a function, extern is one way of function declaration. Extern is one way in which only the indication of presence of the function would be there, but no memory allocation will be there. Another way is function prototyping. So, function prototyping shows its return type, arguments type, and the name of the function. And its significance we will see with the help of an example. For example, when we have swap function over here, we have defined it completely, right? And we are using swap at multiple places. For that, we just take it and place it at the end. Okay. Now, the call to the swap function will happen in the code, but the code as of now does not know what is swap, because swap has been defined somewhere down, right? So I will, when I run this program, I'll get the warning. I'll get some warnings. Okay. The reason is that, as I'd already told you, that swap function we are using before defining what it is. Therefore, it is always better to have function prototyping, so that the sequence in which you write the logic of functions does not matter. So what could be done is that I can say there is a function called swap. It has argument types of integer pointers, and now these many warnings will not come. Okay, this is just the old warning only because of data. Fine. So this is the significance of the function prototyping. So if function prototyping is not used, there will not be any errors, but there will be some warnings. What are those warnings? One warning will be implicit declaration of function, okay, which means that the compiler did not understand what is this function that is being called here, right? So that is one kind of warning. And see, as you can see here, this is the warning, implicit declaration of function. And second is conflicting types. What is conflicting types? So whenever a function is being called without defining it earlier, then the return type of the function is assumed to be int by the compiler. And when the actual definition of the function comes, the return type is different than what the compiler has assumed, which is void. In that case, there will be a warning. So these two kinds of warnings will come if function prototyping is not used and the sequence in which the function is defined and used are not appropriate. Okay. Okay. Lastly, we'll see something about the main function. So main function is something where the processor starts executing the C program. Okay, it is the starting point of the execution of the C program, and there are two versions of the main function. First is the simple one, which doesn't need any explanation. The second one is of this format, argc argy format. As a new learner of the C program, I was always haunted with this thing, and it is actually very easy. So I thought of finishing this video along with explaining what is this. So this is nothing but to take the input from the command line when you are executing the C program. Okay, so I'll quickly show you that. So here the main function I have written is in that format only. Fine. So argc is the number of arguments given on the command line while executing this program, and argv is the list or the array of all those arguments. So you can just run a loop over the number of arguments or over the number of inputs on the command line and print each element. Fine. So let's say ./qsort.o. So let's, how am I printing it? Printf command line input. Okay, so it will, this program will print a lot of other things, so just as a heads up. So see, ./qsort.o was required to execute this. So the first element of the array is that command itself. Now I give, let's say, 5, 12 and yes, let's see. So yeah, all these things get printed. Okay, so I think that's it for today. If you like this video, if you learned anything from it, you can hit a like button, and we'll meet in the next video. Thank you.